Alright, so this video is going to be part 8 of our sequences in series review. This video will be on the DICLARR checklist. Okay, so the DICLARR checklist is something that I used in Calc 2, okay? I kind of came up with the acronym myself, and that was just a checklist of all of the series tests to prove convergence and divergence, okay? So what the DICLARR checklist, what the acronym stands for here is, well, the D stands for the divergence test, the I stands for the integral test, the C stands for the comparison test, but you can also hear it called the direct comparison test, okay, so DCT. You have L for the limit comparison test, LCT, A for the alternating series test, AST, the R for ratio test, and the other R for root test. Okay, so after you check to make sure that that's not the series that you're dealing with is not geometric or not a P series or something, really go through this checklist. Okay, first try the test for divergence, then on to the integral test, comparison, limit comparison, and so on. Okay, now I have little notes for each of these tests, okay, kind of things to look for and all that stuff. So I'm gonna write that down and then I'll get back to you. I guess I'll just do one at a time here. First, we have the divergence test. Now, this should be the first thing that you do when you verify that this is not a P series or a geometric series or anything that's super easy to just see right away. Okay, I know that this is convergent or divergent. The divergence test, really, I mean, you're just taking a limit as n approaches infinity. If it doesn't equal 0, you already know it's divergent. Okay, this should be the first thing that you try to do. Okay, so if you don't try to do it as the first thing, well, you might be missing out on the easy answer, and that's definitely that's why I wrote that down. Next, for the integral test, you're gonna get, I mean, it's gonna be pretty obvious when you have to use the integral test, or at least it should be. I mean, really, the integrals are generally really easy to do. It's never that bad. It's never like some complex partial fraction decomposition, or at least it shouldn't be for you. I never had one like that. So, and especially on a test where there's a time constraint and things like that. Now, next is the comparison test. For the comparison test, the comparison's usually not that bad. I mean, you might have something like 1 over n squared plus 1 where, like something like this, right? Where you automatically know, okay, compare that to 1 over n squared, something like that, right? So it's usually not that bad. You may have something where you need to do like a manipulation to really see that you need to do comparison test. Like for example, if you had something like a n plus 1 quantity squared, I would definitely FOIL that out, and then you could really start to see, you have a polynomial show up, and then you can maybe see that if you have to do a comparison test, it might become a little more clear is what I'm saying. And lastly, you might have to do a comparison that isn't that intuitive. For example, I did an example in, I believe it was in the comparison test problems, where I did a 1 over natural log of n problem. And what we did was we compared it to 1 over n. All right, and we knew that 1 over natural log of n, okay, natural log of n is going to be smaller than n, so we know that 1 over natural log of n is greater than 1 over n, and so that this would diverge. Now that's not something that's completely intuitive. You're going to be, okay, well, of course I'm going to compare 1 over natural log of n with 1 over n, okay? It's not, I mean, it's there, but it's not really there, okay? It's one of those things that I think you could easily slip through, easily slips your mind in a test. So, just be on the lookout for that. If you've gone through all of your tests and you're still not figuring something out, it definitely could be, just a comparison that you might be missing, okay? Now for limit comparison test, all I really have, I mean, when you have your direct comparison test now working, this is definitely your go-to. This is what you want to do, okay? Don't just give up on the comparison. Try a limit comparison test, okay? It's another way to work with that comparison. For instance, I did the example in a couple videos back where we had a 1 over n squared minus 1. Now here, well, this is greater than 1 over n squared because the denominator is smaller. Well, here you can't use a direct comparison test, but what you can do is use a limit comparison test. So I wouldn't give up on it, right? Just go through that checklist. If you haven't got your comparison down, maybe that limit comparison is where you'll actually be able to figure out if the series converges or diverges. For alternating series test, I have down, whenever you have some kind of alternating series, right? So something like a -1 to the n over n, right? The alternating harmonic series, something like that. And as long as it's not like something insanely big, like a -1 to the n with a bunch of other crap just thrown in there, I think that this would be your test, okay? If there's a bunch of other crap thrown in there, like I'm saying, that, if you have a alternating series that happens to be insane, definitely you're going to want to move on to ratio test, okay? I mean, maybe it is an alternating series test problem, but if it's something that looks pretty bad, I would definitely try some ratio test first. Now for ratio test, I remember when I was in Calc 2, really wasn't that long ago, okay? I'm not that old. Anyways, what we would always say is when in doubt, ratio test. That's what my TA always said to us. When in doubt, use the ratio test, okay? You're faced with something really nasty, the ratio test usually can just simplify that right up. Okay, that's why I wrote it simplifies nasty things like a lot. Okay, if you're like I said for the alternating series test, if you're faced with something that's insane, use the ratio test. Now use the ratio test whenever you're faced with something with a factorial, okay? Don't even bother with the test for divergence, by the way. I did an example, I believe, with the ratio test. I'm not 100% sure on that, but it had a factorial in it, and it looked like by the test for divergence, it's divergent absolutely. But you had to go like 7 terms in to realize, what the actual trend was, and that's not something that you're easily going to see with a test for divergence. So really, if you see a factorial, straight to ratio test. Now here for the root test, it's pretty obvious when you have to use the root test. When everything is raised to the nth power, the root test is your guy. Now, okay, this is up to you, okay? You can try the test for divergence if this fails, or you can try the test for divergence first. Sometimes you'll get a really nasty limit when you use the test for divergence with a root test series, okay? So, maybe you want to just try it if the root test fails, so if it's inconclusive, if it equals 1, then go to the test for divergence. It's up to you. If it were me, I would probably start out with the root test and then go to the test for divergence if it fails, okay? But that's just me, though. You might have better luck doing something else. The last thing I want to kind of talk about before we end this video is that, here's kind of an example where DICLARR really won't do you any justice. If you had a series like this, okay, and I forgot to put n equals 1 to infinity. If you have a series like this that has irregularly changing signs, you'll get your numerator to be something like cosine of 1, cosine of 2, cosine of 3, cosine of 4, and just watch the sign here to kind of prove that the sign is changing irregularly. If you draw out your graph, and these numbers are in radians, okay? These numbers are in radians. So, well, here you have, if you're at 180, it's 3.14 radians. Okay, so you got to figure here's something like roughly 1.5. Okay, here's something like roughly, let's say 4.5. Okay, so, and here's roughly like 6.3. I'm just, putting numbers within the general vicinity, but now, so that cosine's positive here and here, so this is going to be positive, this will be negative, 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 and cosine of 5 will be positive, and cosine of 6 will be positive. And you can see that that's not changing, like it's not alternating, it's not all positive or all negative. So what you're going to want to do here, really the only way you can solve this is by proving absolute convergence. Okay, if you prove that this is absolutely convergent by taking the absolute value, okay, if you can do that, then it's therefore convergent. Okay, and most likely you'll be asked something like, is this absolutely convergent, conditionally convergent, or divergent? So that's just something you need to be on the lookout for. Okay, if you have a trig function, at least what I've seen it mostly used for is something like this, or something like an alternating series test, and we've done examples with that. If you want to go see that, definitely go check out those videos. But yeah, so that's gonna do it for this pretty much. I really hope that this DICLARR checklist helps. Okay, it definitely helped to me. So yeah, that's gonna do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.